next, so for our next example on slope fields, we're going to continue our discussion. We're going to take a look at number 2 right here, and we have this dy dx equals x minus y. This is going to be a little bit harder for the next one because on our first example, we only had to worry about the x values. For our next example, we have to worry about the x and the y examples point. So it might be helpful just to list them all out. Negative 3, 2, and I'm going to go negative 3, 1, negative 3, 0, negative 3, negative 1, and negative 3, negative 2. And I'm going to find all their slopes. I'm going to plug them in. Now, you'll probably catch on that there's going to be a pattern. And once you realize there's a pattern, just go with the pattern. It makes these a little bit quicker. So at negative 3, negative 2, I'm going to plug them in here. X is negative 3. My y is 2. This just becomes negative 3 minus 2, which is a negative 5. And that's pretty darn steep right there. There it is. Negative 3, negative 1. My slope is going to be negative 3 minus 1, and that's negative 4. And right away, I got kind of my pattern right here. The slope here, same thing. Negative 5, negative 4. Up, that's just going to be negative 3. Notice it's not going to be as steep. Next one, negative 2. And the last one, negative 1. Notice I use my pattern right here. Negative 5, negative 4, negative 3, negative 2, negative 1. And there's a slope of negative 1. So I use my pattern. The next one will be at like negative 2, 2. Well, what's that slope going to be? That's just negative 2 minus 2, which is a negative 4. And that's what I want right there, so at negative 4. So here's at negative 4. Whoop, that does not look steep enough. Negative 4 is pretty steep, so we want to try to draw at least a little bit steep. And then what about at negative 2, 1? Well, if I look at the last pattern, take a look here. We just kept going adding 1 each time. So the same thing here. If I just add 1 to negative 4, I should just get negative 3. So negative 3, negative 2, negative 1, and 0. And you can verify that. If I'm at negative 2, negative 2, my slope is negative 2 plus 2, which is 0. Now, this is kind of an interesting one because this is telling us we have a critical number right there. Remember, this is the derivative of our graph. And when the derivative equals 0, we have a critical number. So just a little bit free for us. All right, so let's take a look right now. Let's look at the pattern. Take a look. As I go from negative 3, I'm at negative 5, but at negative 2, I'm at negative 4. So I can kind of use my pattern here at negative 1, 2. My slope would be negative 1 minus 2, which is a negative 3. So if you notice, we've gone from negative 5, negative 4, negative 3. So I can use that. So this is a negative 3. And if I know down, and as I head down the graph, we're just adding 1. So negative 3, negative 2, negative 1, 0, and then that's going to be 1. And if we're heading, to the right, take a look, negative 4. No, I'm sorry, at negative 5, at negative 4, and here at negative 3. This one should be right here at negative 2. So I can go negative 2, then going down, negative 1, 0. Whoop, missed it. There we go. The 0, 1, 2. And keep going. Whoops, sorry, that was negative 3. So over here sorry, lost track where it was. So here at negative 5, negative 4, negative 3, negative 2. This should be a negative 1. So we're going to get negative 1, 0, 1, 2, 3, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. Your graphs don't have to look perfect by any means, but you want to kind of make sure that your slopes kind of look like this is a slope. If this is a slope of 1 right here, oh, everything's going crazy. There we go. If this is a slope of 1 right here, make it look like a slope of 1, as close as you can. All right, so there's our slope field. Now, this does not look like any function that we know, but let's talk about this. What do you notice is occurring when dy dx is 1? So they're telling what you notice when the slope is 1. Well, if I look over here, it looks like it is a straight line. It looks like a line. And it is. And anytime we see straight lines in the slope fields, we're thinking this is a slant asymptote. It's an asymptote. So that's what we kind of say. If we see a straight line, therefore this is an asymptote. And you should remember what an asymptote is. You can't cross them, you can't touch them. Horizontals are different, but this would be in our case an oblique asymptote or a slant asymptote, depending on how your teacher talked about it in pre-cal. Now the next question is really kind of neat because now they're saying, let's make this unique. We talked about this earlier. Up above, in example number 1, when we graphed the slope field, we said this was not unique. And that's because we're given this plus c right here. So earlier this year, we learned how to solve for that plus c by plugging in an initial condition, and that's what makes it unique. And that's what we're doing down here. By plugging in the point, this is our initial condition right here. And this makes the function unique. So this will now become unique. So to make this unique, let's plot the point. -2, 1, 2, -1. I want to plot the one function that goes through here. Remember, we have infinitely many functions, but we want only the one that goes through this point. And as we head towards the right, it's going down until it reaches around here, around this point. Notice the slopes here are all 0 along this line right there. So I know that my function, if I'm going down here, it has to turn around the same point. So right there where my slope is 0. And as I move up, keep moving to the right, now it's turning around. It's going to approach that straight line that we talked about. It becomes asymptotic. If I get rid of let's see if I can get rid of the red here and you can see it better. There we go. If I get rid of the red, there it is right there. And you can see that. Okay? So there. Now, if we head towards the right side, to the left, it's just getting steeper. So notice, it's getting steeper as I move towards the right or the left. So as I keep moving to the left, it's going to get steeper and steeper and steeper. And again, you kind of want to make it match your slopes. And this is what our function here would look like. Now, but what if we tried a different point? So I'm going to do a different point. So let's try the point. Let's do in purple. We'll do purple. What about the point? Oh, let's say 0, 0, the one that goes to the origin. Well, at 0, 0, it looks like this. It's already at 0, so it's going to be moving up. Notice it's going to be in the same shape. As I move to the left, it's going to get steeper and steeper and steeper. Notice it is the same shape, but we have two different starting points, so they're not going to look exactly the same. They're at different places. They're at different points in their graph. And that's because of our slope field. All right, so let me go and put that line back in here. Remember, sorry, I'm going to put that line here. Remember, this is that asymptote right there. Okay, so be careful. All right, so let's take a look at the next example here. Let's go and graph this one. Now, this one's kind of a neat one because we have a problem here. We have x over y. So let's try plugging in our points. Just plug in a bunch of points here. -3, -2. If I plug in my slope, it's going to be 2/3. Ugh. Okay, that's not that bad. There's about 2/3, right? Nope, less than that. I would say less than that myself, but let's see here. About 2/3. If I plug in -3, -1, we're looking at a slope of 1/3. Okay, even less steep. Plug in -3, 0. Let's take a look at what happens here. I get 0 over -3, which is 0. So it becomes horizontal. If I plug in -3, -1, oh my gosh, I'm plugging away the wrong points in here, aren't I? Let's take that. We are going to erase these because obviously I did some arithmetic mistakes here. So let's go and start here. There we go. Because I don't know how to edit very well. We'll start here. So -3, 2 is what I wanted. And that becomes -2/3. There we go. So like -2/3. -3, 1 gives me negative 1/3. So a little bit less. And then here at 0, there we go. All right. All right, now let's try it. Negative 3, negative 1. Our slope here is positive 1/3, so it just goes in the other direction. Negative 3, negative 2, we get positive 2/3. There we go. All right, sorry about that. Now I can kind of figure this out here. So let's try the next ones. Let's try a few more. What about negative 2, 2? Well, that's going to give me a slope of negative 1. So it's a little steeper. And we just kind of keep going. Negative 2, 1 gives me a slope of negative 1/2. And if I'm at negative 2, 0, we just get 0. So notice what happens when y is 0, our slope is just 0. So I can do that real quickly. 0, 0, 0, 0, 0. Oh no, I made an error. Don't put anything there at the origin yet. We'll talk about that in a second, okay? All right. So we can keep going. What if I'm at the slope? Running out of room here. What if we're at the point negative 1, 2? Well, that's going to give me a slope of negative 2. Negative 2. And what if I'm at the point negative 1, 1? Our slope is negative 1. And down here, we're just kind of flipping it. So this is going to be just positive 1/2 and positive 2. Positive 2 here, and what's that? Positive 1 there. All right, just keep going. Remember, on the bottom, we're just going to flip them. So if I'm at 0, so if x is 0, take a look here now. What happens if I let x be 0? Oh no, this is a problem. 0, 2. Let's take a look at the slope if we try plugging that in. We're going to get 2 over 0. Well, that is a D&E. This is our definition of a vertical line. So take a look here. And when y was 0, we said we just drew a bunch of horizontal lines. But when x is 0, it becomes completely vertical. So I just draw my vertical. I'm going to draw vertical lines. Now notice, I'm not going to put anything in the center. Just leave the center open for now. We'll talk about that in a second. And now we're going to pick a new point. Another point. Ready? Point 1, 2. The slope would be just, if we pick that, it would be 2. And you can probably notice the pattern. If I pick 1, 1, the slope here is just going to be 1. And over here it's flipped, negative 1, negative 2. And if I pick the point, let's see here, 2, 2, our slope is also 1, 1. And if we pick the point 2, 1, our slope is 1/2. And if we go underneath, we're just going to flip those signs. So this will be a negative 1/2, and that'll be a negative 1. So negative 1/2, negative 1. And our last row here. Here we go. 3, 2. Our slope is 2/3. So 2/3. And if at 3, 1, our slope is 1/3. I told you, this is the most exciting thing you can do all day long. So slope of 1/3. And down here, we're just going to change those signs. So a negative 2/3 and a negative 1/3. So negative 1/3, negative 2/3. All right. Wow, looks kind of like a star pattern. So let's see what happens if we want to be at the origin. What if we plugged in 0 over 0? Well, then our slope here would be 0 over 0. You might recall earlier, this is what we call indeterminate. In other words, we don't know. We can't graph anything here. So we don't know what this looks like. It's indeterminate. So put nothing there. All right. Well, I hope you enjoyed this video. I know there's a few little errors in there, but this stuff is not necessarily always the easiest, and it's good to see mistakes that even teachers like me make all the time. But notice I did go back and we went back and we fixed them, and that's the big thing. If you make an error, make sure you go back and fix it, so you make sure you understand what you are doing. All right. I'll see you in the next video. Bye bye.